This video is for Calculus BC, and this is 8.2, Integration by Parts, okay? So integration by parts is used specifically when it's integration of two functions being multiplied, but U substitution does not work. So these look a lot like U sub questions, but when you try to do the U sub, remember how we talked about if there was a number missing, you can multiply that number in with its reciprocal. But if there was a variable missing, we couldn't do that. That's where integration by parts is going to come in handy. So let's talk about the formula first. And we have the integration of u times v prime. There will be two things being multiplied. You are going to have to pick who u and v prime is, and we'll talk about that in a second. And the answer to the integration is going to be u times v minus the integral of v times u prime. And then you just solve this integral, which should be a simple from calculus AB integration. And if it's not, you just do the process again, okay? So first, we have to always fill out this chart. The u and the v prime is going to be what's in the given, and you have to pick who is u and v prime, okay? When picking u and v prime, usually u is the algebraic function, and v prime is the transcendental. If it gets more complicated than that, you're going to choose u according to the order of LIATE. Logs, then inverses, then algebraic, then trig, and then exponentials, okay? Once you've done that, you're going to draw a backwards z to write out this part of the formula, okay? So again, the given is the u and the v prime, and it's going to equal, the next step is u and v minus the last part, you're going to solve for the integral of v and u prime. So given equals multiply these two minus the integral of these two. Okay, if you can draw this chart out and write the backwards z, these questions are really not that bad. Okay, the first example that I want to show you is how we can quickly look like a U sub question. Okay. On this question on the left, if I look at the two functions, I have 2x and I have e to the x squared. Okay. The exponent here is x squared. If I were to treat this as a U sub, my u would be x squared, which means my u prime would be 2x. So I can spot here my u and I can spot here my u prime. I can rewrite this as the integral of e to the u and write u prime as du over here. Antiderivative of e to the u is just e to the u plus c. Plug that u back in, and I'd have e to x squared plus c. Okay, here is a u sub question. Old news, okay? Now, when I look at this one, my exponent is an x. The derivative of x is 1, and here I have something more than just the coefficient of 1, which is what lets me know that this is not a u sub question. Okay, so I need to treat this with integration by parts. Okay, if I'm going to do integration by parts, I need to start off by deciding who is my u and who is my v prime. Okay, we said if there's just algebraic and transcendental, that the u is going to be my algebraic and my v prime is going to be my transcendental. The next part of my chart is a u prime doing the derivative and a v doing the antiderivative. Okay, the derivative of x is just 1, and the antiderivative of e to the x is e to the x. Okay, so now if I follow my z, my backward z that I should draw, right, I have that e to the x and x is in my original question, and it equals, the next part of the z is the diagonal, x times e to the x minus the integral, the last part of my z is these two being multiplied, e to the x times 1. E to the x times 1 is just e to the x, and I write my notation of dx. This part is already solved. There's nothing to do here. The antiderivative of e to the x is just e to the x, okay? Oh, don't forget here. Look at that. I almost forget it here. Plus c. Okay. And that is my answer. You just solved your first integration by parts. It was an easy one. And if you ever want, you guys can always check an antiderivative by solving a derivative. I would do here product rule minus just derivative e to the x, derivative of a constant is 0, and you can double check that you get this as your answer. This next question reads the integral of x times sine of x. Okay, so first step I want to do is create my chart. I have u prime, v prime, and v. All right, so remember algebraic is almost always the u, especially if there's a trig function. So I'm going to put my x as my u and my sine of x as my v prime. Okay, next step is to solve the next row. Derivative of x is 1. Antiderivative of sine is a negative cosine. Okay, if I follow my backwards z, our little trick here, the first part, the multiplication of sine and x should be your question. Then equals the diagonal of my z, x times a negative cosine of x, and then minus the integral of the next two being multiplied, 1 times a negative cosine of x. Okay, now I can clean this a little bit and I can say negative x cosine of x. I can bring out this negative and now say plus, and 1 times cosine is just cosine of x. Bring down this part. The antiderivative of cosine is a positive sign. And don't forget your plus c, and you're done. So these questions are really not difficult, guys. As long as you just remember that backwards z. You can fill out the chart and you do the backwards z. Now, this next one may not appear to be integration by parts question, okay? Because there's only one term. We have yet, believe it or not, in all the calculus you've learned, you have yet to learn an antiderivative for ln of x. So let's treat this as if it's saying 1 times ln of x, okay? Now, if you remember that chart at the beginning of this video that I said picking u in the order of L-I-A-T-E, that L stands for log. Anytime you have a logarithm, that should be your u, okay? So we'll put ln of x as my u and my v prime as 1. Derivative of ln of x is 1 over x, and the antiderivative of 1 is v, okay? If I do my backwards z, across should be my question, 1 times ln of x equals, now I do my, look at me, I put a v. Crazy lady. Antiderivative of 1 is x. Sorry about that. Diagonal would be ln of x and x. I'm going to write the x first just so it looks a little better. Minus the integral of my last part here, 1 over x times x dx. Okay? Rewrite this part. Minus, if I multiply x and 1 over x, I get x over x, which is just the integral of 1. Antiderivative of 1 is just x. And there's my answer. So I told you earlier on that you could always check these questions by doing the derivative of your answer. Remember when you were like in middle school or elementary, you would check your division by then multiplying and vice versa? We can do that here, okay? So if you ever have any doubt and you have time, I want you to check. okay? If I'm doing the derivative of this, I have to take one term at a time. The derivative of this first term would be product rule, okay? So I would write first times derivative of the second plus derivative of the first times rewrite the second, right? This would be my first term minus derivative of x is 1, there's my second term, plus derivative of a constant is 0. And now all we have to do is clean. X over x, right, is just going to give me 1 plus 1 times ln of x, and then minus 1. We don't have to write the plus 0. The positive 1 and the negative 1 cancel out, and I am just left with ln of x, which, if you look at my original question, is what I was working with. All right, last question for this lesson, and I'm going to up the ante a little bit. I'm going to give you one that's a little more complicated, okay? So, initially, I told you two things being multiplied can't use u sub, and when I have algebraic and trig, then the algebraic is going to be my u, and the trig is going to be my v prime. Okay? Next part of the chart, derivative here is 2x. Antiderivative, be very careful, and I'll come over here to do it slowly for you. The integral of sine of 4x is a u sub question, okay? Where my u is 4x and my u prime is 4, which means this is missing a 4 and needs a 1 over 4, okay? So my antiderivative would be 1 over 4 integral of sine of u, okay? And this gives me antiderivative of sine is a negative cosine, so I'm going to bring the negative to the front. And if it's of u and I need to put my u back in, maybe you can get a little faster at these, okay? So this is a negative 1 over 4 cosine of 4x, okay? Be careful with that. There's the first part that gets a little tricky. So now my integration, remember the backward z, this is my question. The next part is these two being multiplied, so negative 1 over 4 x squared. I'm going to put the negative 1 over 4 first, so. And then the cosine of 4x. This part is just going to be brought down every time. I don't need to touch it. Minus the integral, and I have here 2x times negative 1 over 4 cosine of 4x, okay? I'm going to clean that a little bit. I'm going to take out the 2 and the 1 over 4, which is going to give me a 1/2. I'm also going to take out that negative, and it's going to turn positive. And now I have the integral of x times cosine of 4x. Oh, I forgot my dx up here. So I cleaned up a lot. What I have left that's really the hard part here is this integration. Okay? That's what I have left to work with. Now, hopefully you catch that this in of itself, just like the last part, is also an integration by parts. So I have an x times a cosine of 4x. This is not going to work with u sub. I could even see how that 4x works out. Okay, so I'm going to have to do integration by parts one more time. Okay, my u and my v prime. Remember when I have algebraic and trig? Algebraic is my u and trig is my cosine of 4x. Okay. Next step is to find my u prime, which in this case is 1, and my antiderivative here. So if I had this whole 1/4 coming out for antiderivative of sine, it's also going to happen here with the cosine. The difference is antiderivative of sine was a negative cosine. Antiderivative cosine is a positive sine. And I would replug in that u. If you feel the need to do this slowly like we did here, go ahead and do so, okay? Next step, I'm going to bring down this entire part. Just rewriting it, okay? Now here, I'm going to put a bracket because my answer from this is going to have to get multiplied with that 1/2. So be very careful, okay? The next part of this, remember, my question should have both of these. My next step is these two being multiplied. So I have x times 1/4 sine of 4x. Then minus the integral of these two being multiplied, which is 1 times 1/4 sine of 4x dx, and now I can close my bracket. You see how this 1/2 is going to get multiplied to the entire answer of that? So let's start working our way to cleaning a little bit. Now here I can multiply the 1/2 with the 1/4 and the x, which is going to give me 1/8 x sine of 4x. Now be very careful. I'm going to even color code this here. This 1/2 went into this term, and it also has to go into this term, okay? And remember that I am allowed to bring out this coefficient to the front. So watch how I do that here. I have 1/2 times 1/4 times 1 is going to be a minus 1/8, and then just the integral of sine of 4x. Okay, so now all I have left to do, all right, like if we haven't done anything, is just this integral. Okay, so let's solve this integral really quick, and then I'll bring all this down. And if you look, we already solved this integral earlier on. So your work should be very easy. So this is a negative 1/8 times, we said the answer to that antiderivative was negative 1/4 cosine of, whoops, almost forgot my x there, 4x. Don't forget your plus c here, okay? So now I'm just going to rewrite everything nice and neat. I have negative 1/4 x squared cosine of 4x plus 1/8 x sine of 4x minus a negative 1/8 and a negative 1/4 is going to be plus 1/32 cosine of 4x plus c, and we are finally done. Told you this was a trickier one. Oh, got it. Be careful, there, almost crossed out my work. And that's it.